As you walk through the forest, there are many things that you tend to notice right away. The trees, bushes, flowers, very noticeable and large vegetation. There's another part of the forest that tends to go unnoticed and underappreciated because it's mostly hidden underground. This integral part of all ecosystems is roots. There are many structures and components of roots that affect how they interact with their environment. When you think of roots, you tend to think of a few strands that go into the earth, but characteristics of these roots vary tremendously, even within the same species of plant. Some of these characteristics include root depth, root length density, and root diameter. Even the tensile strength of the root affects how it interacts with the environment. Including these morphological traits, the functioning of the roots also affects the surrounding ecosystem, such as how the roots affect the soil. These traits and interactions will be described throughout the course of this video. A main characteristic of roots is that they anchor vegetation to the earth. Keeping the plant firmly secured to the ground allows the plant to survive, which in turn provides food for other organisms. Pull-out resistance, which is how difficult it is to pull the plant from the ground, can be affected by depth and density of the roots. If a plant is easily pulled out, like by wind or animals, the plant would die, which would decrease the amount of regrowth vegetation and food for other animals in the area. Total anchorage is also related to individual root tensile strength and root architecture. Tensile strength, the amount of force it takes to pull something until it breaks, varies within species of plants, root diameter, soil, and moisture. Plant roots with higher tensile strength can contribute more to the enhancement of soil strength. This strength is required for tree anchoring. It wouldn't be good if a strong gust of wind could cause a tree to crash to the ground simply because the roots snapped under the force of the wind. Having all of the trees fall down in the area would dramatically affect the animals living in it. Another important feature of roots is that they provide structural stability to the soil itself. Denser, finer root systems bind soil more effectively than coarse root systems. You can almost think of it like having a lot of little fingers holding soil rather than big fingers with large spaces in between where the soil can move around. Root diameter also affects the density of the soil. For a root to grow, it needs to push aside the soil as it goes. Large roots increase soil density because they need to take up more space, whereas finer roots can actually make the soil more porous. Roots near the surface of the soil can displace the soil upwards, but deep roots cannot displace that soil due to the volume it would need to move. In this case, they make room for themselves by compacting the soil around them, which makes the soil more dense. This compaction affects the porosity, water conductivity, and aeration of the soil, which in turn affects biochemical interactions in the ecosystem. If the soil is really compact, neither water nor air can seep into it easily. This would particularly impact certain bacteria that live in the soil if they require a certain amount of moisture or oxygen to survive. The anchorage of the plants, as well as the soil stability that we discussed earlier, helps to protect sloped areas against land and mudslides. Wind and water can carry soil and its inhabitants away and cause erosion. Deeper roots act to stabilize soil at great depths, which is especially important in sloped areas where the soil movement is easily affected by gravity. Root branching, which is the sprawling network of roots, increases stability and increases the resistance to that soil movement and erosion. Woody vegetation, such as trees, are particularly helpful in preventing shallow landslides. In shallow soils, tree roots can sometimes penetrate the entire soil mantle and anchor directly into the bedrock, which is more secure and stable. This stabilization helps to keep the tree and roots in place, which in turn keeps the soil in place despite rainfall and wind. Now that we've covered the morphological traits of roots that affect the ecosystem, we can take a look at how the actual functioning of the roots affects the surrounding environment. These functions include carbon cycling, nutrient cycling, and interactions with soil organisms. Carbon cycling is how carbon naturally moves from one part of the earth to another, like from decaying plants and animals to the atmosphere. Carbon is an extremely important component of all organic living material. Dead roots input a considerable amount of carbon to the earth. When the roots die, they allow their stored carbon to be taken up by other organisms and even other plants. The amount that the roots contribute is affected by how deep the roots were when the root died and the root lifespan. For example, there are certain pathogenic fungi that accelerate root decay, which would increase the amount of carbon input to the earth. Roots also have a large impact on soil nutrient availability. This nutrient cycling works much the same way as carbon cycling by transferring nutrients from one organism to another or within the atmosphere. This movement of nutrients can also dramatically influence soil pH. The pH of the soil can increase or decrease by up to 2 units in the rhizosphere, where the roots are located, due to the release and uptake of ions by the roots. This control of the pH influences what organisms and other plants can reside in that ecosystem. Organisms such as fungi and rhizobia interact directly with the root systems and play a role in helping the roots extract nutrients from the soil. Roots release low molecular mass compounds such as sugar, amino acids, and organic acids. Bacteria can feed on these carbon-rich compounds, and then other organisms can then feed on that bacteria, and then that continues on down the food chain. Water uptake and root respiration also directly influences the organisms that can live in the soil. They do this by affecting the amount of oxygen present in the soil, which then affects microorganism respiration. If a particular organism needed a lot of oxygen to survive and the roots were extracting most of that oxygen, then that microorganism could potentially be at risk. So now we know quite a bit of information regarding how roots directly affect their ecosystems. By applying this knowledge, we can actually use roots to our advantage. An example of this would be that many vineyards will grow their grapes in horizontal rows on a hillside instead of vertically. This is because the roots can keep the soil in place so that the large amounts of water that are needed to grow the grapes doesn't erode the hillside and wash away the nutrients kept within the soil. In this particular case, the roots are offering soil stability. So as you can see, roots directly affect their ecosystems by providing anchorage for plants, providing soil and structural stability, which helps protect against landslides, and providing a source of food for some animals. They also affect their ecosystems through their processes, such as carbon and nutrient cycling, and directly interacting with soil organisms like fungi. So if you're ever walking through the forest or any area with vegetation, remember that there's another incredibly important part of that ecosystem other than simply trees and flowers. It's just hidden underground.